On to Chapter 2.6, the algebra of functions. So the first problem in the online quiz starts with a similar problem. And they're a little confusing. I didn't want to do that problem. By the way, it's the only version they have on the quiz. So I came up with something slightly different because it has the same idea. It says write the formula for the area of a circle in terms of its circumference. What we do is we start out with the formula for the area of a circle. And we're also going to write the formula for the circumference of a circle, which is 2 pi r. Now, when it's asking for the area of a circle in terms of its circumference, we want to rewrite area, but we are not going to use r. We're going to solve for r in our circumference equation. So instead of plugging in an r into the area, we're going to plug in the r equivalent of c over 2 pi. And that gets squared. One thing to notice, let me move things around a little bit. I'm going to finish simplifying because I can do a little bit of reducing there. A is equal to pi times c squared all over 4 pi squared. And I was aiming at that because I knew I could reduce it by pi. So our final formula for area in terms of the circumference is going to be area is equal to circumference squared over 4 pi. And like in the first two problems in the quiz on XYZ homework, now we want to do it the other way. So we're going to write a formula for the circumference of a circle in terms of its area. Now, I'm going to solve A for R. And my pi looks terrible. Technically, we should probably do plus or minus in front of A over pi, but these are all distances or by areas, so it doesn't make sense to have a negative. Okay, so r is equal to the square root of a over pi. So I go back to circumference, and instead of using the r there, I'm going to use square root of a over pi. Now, because the pi is inside the square root and the other pi is on the outside, I could simplify, but it would be crazy fractional exponents, and I don't see a good reason to do that. On to problem 2. We're going to talk about domain. We're going to start talking about domain. These are all basically function operations: add, subtract, multiply, and divide. So the first two, first of all, since we have two separate functions, I'm going to identify the domain of both of them just to start with. They're linear functions. By the way, linear functions and polynomials like quadratics, cubics, quartics, all of those have unrestricted domain. That means any x can go in there. So both of these, being linear equations, have unrestricted domains. So as we work, we're going to see if the operations themselves will give us a restricted domain. We're just going to take f minus g of x. And this is slightly new notation. The notation that I'm more used to is f of x minus g of x. But if you notice, I think what we have there takes slightly less pen strokes. And I've seen this new notation more commonly lately. But all it's asking us to do is take function f and subtract from it function g. So 2x plus 1 minus, and be careful with subtraction, you will, with more than one term, you will have to distribute. So I always put that in parentheses. So we get 2x plus 1 plus 5x plus 1. And that looks like 7x plus 2. Now, because we have a linear equation as a result, our domain, again, is unrestricted. Part B, though, is a fraction. And so when we build function f over function g, we have some domain issues. Now, here's the interesting thing about this. It's not reducible. Both of those, both the numerator and denominator are totally factored. I guess I could factor in -1 from the denominator, but I don't see any good reason to. And by the way, if you enter exactly that into the quiz, it'll be happy with it. But let's talk about domain. Because we have division by 0 with the -5x minus 1, we have a restricted domain. So I'm going to take that -5x plus 1. I'm going to do a little calculation. Our problem would be if this 5x minus 1, if that's equal to 0, then we have division by 0, a domain restriction. So I'm going to add 1 to both sides and divide by -5. So all the x's work except for x equals -1/5. And the way we do that is -infinity to -1/5 union -1/5 to positive infinity. Running out of room. And so that's our domain. On parts C and D, we don't have to state domain. It doesn't make sense. And so here's what I'm going to do. I'm just going to take f plus g and plug in a 1. I can put f plus g together and plug in a 1, or I can plug in a 1 as I'm working. It doesn't really matter. So f plus g is going to be 2x plus 1 plus -5x minus 1. So I did both. I went ahead and added my two functions and substituted at the same time. And it looks like my final answer is -6 plus 3, or -3. Same idea with D. Because if I write my multiplication, well, now I have a bunch of algebra to do. I think it's just a whole lot more efficient to plug in my number right away. So I get 6 plus 1 is 7, and -15, -16. So 7 times -16. And that, when I multiply, gives me -112. Okay. I'm going to wait. I'm going to stop this video. It's getting kind of long. I'll see you on E.